This week we'll be talking about attention blocks in an LLM. To be short, there is multiple attention blocks in an LLM, and they contain 96 of these vectors that we'll be seeing in probably slide 3. But to keep it short, an attention block's purpose is to gather many context clues and basically predict the next word from the context clues. Right here we have a fluffy blue creature roam the verdant forest, but it's cut off, but that's basically what it is. And each one is basically like a little vector. And the queries is 128 dimensional, and any adjectives is basically would in that sentence it basically means is there an adjective in front of the next word, which in the word that we have is the creature, and it's fluffy and blue. Right here, you can see these are the vectors, just like in the many LLMs have with numbers. Each one of these is a vector. Then we have the layer where all the vectors get averaged, and then the next one where it finally gets averaged. Basically, what these are doing is basically being put on a graph. As you can see here, we have an American shrew mole. You see there's 4 different types of moles. There's the mole in science and the mole number, and then the American shrew mole. And I don't even know what that is, but that is there. So basically, it is like a way to see it is like gradient descent in my eyes, where it's telling you to take steps into each one. As you can see here, this is the first step. It was American. So we can have the mole. We have both moles here, and then the animal. That's probably American, which will probably take us to either one of these steps. But then it needs another direction. So we'll take one step here, and then the other direction would be a shumo. Then I'll be like, oh, shumo is not the emo or the number, it is the animal. So we'll take another step over here, into which it'll go to the American shumo. Like see here, we have the attention pattern. Looks right here is this side is the masked form. This is the regular form. The regular form is numberfied, but to make it simpler, these are like the circles right here, which is like the big circle is when it comes to number 100. These are the vectors and the queries and the weights. And we have right here the patterns. The way how it works is it starts right here, and basically if it says A, the number will get, now put a number here depending on what should be next. So as you can see here, it's zero point 0.7. You want to put AA as the next word. But you can see here, A fluffy. So the next word after A fluffy would be a fluffy A. It could be the next, obviously probably right here. It doesn't show us the next word because it's negative. Then it's the same thing. See right here across, it's like averaged because it knows that these words might be the next ones. But we have here a fluffy blue creature. See here, fluffy could be for creature, which is why it's bright, or it would be like a big circle like this. And then blue, you can also label a blue creature, which would be like this. Technically, to get these big numbers is basically like a noun with adjectives next to it, to which you get the big number. So there's this way of doing it, and then there's the mass version of the attention pattern, which where it shows saying that you won't need all these to learn what the next word's going to be because you want to be told what the next word is. So the way how they train it is they get rid of all these future words, you blank it out to 0, and then after that, like the averages become big circles. Into which then it will start training its process, saying like, okay, this could be next word, this could be next word, this next word, and it will learn, which is basically ends the attention block of learning. And to simplify it, like I said in the beginning, the way the attention block works is gathering clues to learn about the next word. So like again, we could use like there was a wizard named Harry. It could guess instantly on who the wizard could be because it would be Harry Potter because he's a wizard. But it could also guess family of Harry, into which the context clue would be there's a real person named Harry, and it'll guess the real person is Harry. Into which this is how it works into finding out who would be the next word, because you'll guess the wizard, it knows it'll be Harry Potter, and then it'll guess the person would be royalty would be Harry. In the end, that's how basically this whole block is working, and it uses a lot of attention blocks. It uses 96 of them in each one, and there's multiple, as we saw in past LLMs, to make the process run faster and able to train better. And that'll be it for this week.